Hi, my name is Helge Maus from pixeltrain. In this tutorial I want to explain how to achieve this effect which you see here on the screen. It's my torus wave example which I concepted for a motion graphics tutorial, and some people asked me how to achieve this effect. In this really basic tutorial I want to teach you how to approach an effect like this. So we want to talk a little bit about analyzing what are your needs and how to set this effect then up. You will learn a little bit about VOPs and how to use VOPs and information for pscale rendering, and I think it will be fun. So let's get started. The first thing we want to talk about is how this effect here works, and this is the analyzing process you normally have if you R&D something. You see something and you try to achieve an effect. So if you analyze this video here, you see a whole bunch of equally distributed points over an object, in this case here a torus. And these points here are activated and deactivated somehow by a noise in this case here. And what you also see is that these points will grow and shrink while this noise is moving over the surface. So what I used here is the pscale attribute, which Mantra and all the other external render engines, for example like V-Ray or Pixar's Renderman, will understand. So what we need to do now, and this is the setup we are after, is first distribute equally spaced points over a surface, and then we need a noise which runs over the surface, and with the help of the noise we will scale the points. That's the thing we are after. Let's get started in an empty Houdini scene, and as a test object we start with a torus. So let's lay down a torus here, and to make sure that we have equally spaced points we can use the original mesh here, but instead of changing rows and columns we want to have it more flexible in our setup. So let's lay out a subdivide node and hook it up, and with the help of the subdivide node we can change the depth of this subdivision, and that's the way you increase the resolution of the mesh. So we can change this later. And we name this node here point amount, for example. Okay. The next thing we are after is that we only need the points, but not the surface himself. To remove all the polygons and edges without removing the points, we can use the add node, which we normally use inside of Houdini for generating points and polygons, because inside of this node we have a parameter which is named delete geometry but keep the points, and that's exactly the thing we are after. So remove everything. Next step, we now need our noise pattern, and with the help of the noise pattern we later want to scale the points. For achieving this effect we want to use a VOP, and if you look here into the list of VOPs you have to decide which kind of change you want to do, and we want to work on the points. So the most obvious VOP we can use is the point VOP, but there's also an attribute VOP, and if you take an attribute VOP, hook it up and set the display flag, you see that you have here the run over option, and inside of the run over you have all the different kind of surface details like primitives, points, vertices and so on. So all these VOPs in the list are really the same attribute VOP, and here you can change what you want to change, in our case the points. Display flag is set, we dive into this VOP now, and to make a little bit more space I normally do something like that. I hold down my Option or Alt key and I click on this little field here, and so I change now horizontal to vertical alignment, and then I release the Alt key and click here again, so that I have my parameters now on the right side, and here in this area, which I can now make a lot bigger here, I have my network view, and so we have a little bit more space for working. Also I save this file really fast in my Houdini projects. Let's name it test. Okay. That is the first step now here. The next thing we want to think about is how to get a noise running over this surface, and for this we take a turbulent noise To drive a noise, we always need something which changes. In our case, it's the position in space. So we hook up the P from the position with the position here of the turbulence noise. And because this VOP is now running over every point, and every point has a different position in space, you have always another output. To see directly this output, we get here the noise. And this noise, if you hover with your mouse over this output, you see in the bottom part of my window, it's a float parameter. So only one value, but Houdini is able to convert it on the fly here. And so I hook it up to the CD so that you can see how this noise looks now. And you will see that now every point is colored here differently. To make it more obvious, I changed the size of the points. You can do that by pressing the D key, like display option, over my viewport. And if you go here to geometry, you can see that you have here a point size under particles, and I increased the point size to 5, for example. They are now really big, and so you can see them now really good. To animate now this pattern here, we can change one of the other parameters. And if you see that you have a noise in space and you want to move in the noise, you can use the offset of the turbulent noise. You can test it here by changing the offset by middle mouse button click and moving. You see this is the X direction, and the pattern moves now in X direction, Y direction, and also Z direction. Okay, let's drive this here with something which changes while I'm animating. And we have several parameters for that. We have here the frame number, which we have in the moment, it's 1, and also the time, which is the time in seconds. Frame number changes really fast because we jump here in every frame one full value. Here the time is a little bit slower, but you will see that it's still too fast. So let's hook it up directly and see what we get. So we make a connection between time and offset. And be aware that you get this dotted line here. This dotted line you always get if you make something which Houdini doesn't like too much. Why? Because the output of time is a float and the offset here is a vector. And what Houdini does, it casts now the type of this output here, and he generates from a float a vector. We get all 3 vector parts exactly now the same value, so it works somehow. But Houdini lets you know that something is not fully correct, and so you get this dotted line. Switch on the real-time toggle here and press play, and now you see, we have now a moving pattern on the surface. But like I've said, it's really fast, and this is something I don't like. So I want to have more control about that. For control, we can use a multiplier. Add a multiplier here. One important thing about data type and casting is that this multiply node, as many other nodes inside of the VFX builder, is a neutral node in the moment. So if you hover over the input 1, you see that this input can have floats, vector 2, vector 4, and so on. And the first connection you do sets the type of data which this node works with. Keep that in mind. So if I now take, for example, the time, which is a float, and hook it up, you see now the color changed. The output is now a float, and this is now a float node. If you scissor this, so you deconnect by holding down the Y key and draw a line, you can hook it up, for example, to CD, which is a vector, and you see now the node is a vector node. Always keep that in mind. The first connection sets the data type. Now, in case we take now the time, and we need an external multiply here. So how to do that? What we want is we want to have later user interface on the VOP so that we can set the data from outside. Otherwise, you have to go inside of this VFX builder all the time. To do that, we have to promote this input. And there are 2 ways of doing it. One by hand and one automatically. By hand, it's done like that. You add a parameter node here, and you see this is an external parameter. You see it in this little knob here, and you hook it up. Okay. Then you go into the name of this parameter node and you change it Be aware that every node which has the same name is hooked together with the other ones, so try to get a unique name. In our case, this is the speed multiplier, and that's exactly the name I'm after, speed mult, and the label is the thing the artist from the outside sees later. So I name it speed multiply, so that's clear what's going on. The default value is 0, and that's it. And if you now go to the outside, you see that on the user interface, we have now this speed multiply slider, which now generates the data inside of this node graph. And this is the multiplier we have here now. So we can try it directly. We hook it up to offset again. And if we go now outside, press play, nothing happens because speed multiply is 0. But if we go to 1, you see it's animating again, 0.2, yeah, works. Great. So set it back to 1 and dive in our network here. And I name this multiplier also directly speed multiplication so that we don't have a double in the names here. The next thing I'm after is that I want to set the direction of the pattern flow. Like I've told you, we have done here something which is not 100% correct. So we have here a vector and here we have a float. So we drive all 3 offset values at the same time. What I'm after, and for this I cut this line here, is that I want to set the offset here in the direction which I define. For example, if I zero out them here completely, and I would animate, for example, here the Y component of the offset, you will see that this pattern flows now upwards. And if I change here the X direction, it flows in X direction. So this is something I want to control from the outside. So how to do something like that. The multiplier here is a value, a float value, easy. But what we need here is a vector. We can change values from float to vector really easily by converting them, for example, with a float to vector node. But what we want is really decide from the outside in which direction it goes. And to do that, we give the artist a vector outside, which he can set, and then we use our speed multiplication for defining the length of the vector. Sounds complicated, but it's really easy. Let's take another parameter node. And this here, so a speed multiplier, and this here is the direction. Okay, and we say this is the direction. We need as a data type this time a vector. So we have 3 values here. We can set them to 0, 0, 0. That's okay. And then we take this vector here and we multiply it by this value. So take a multiplication node, and now we will remember the rule which I told you. If you first connect now a float here, this node is calculating floats. You can add a vector here, but you will see that it stays in the float word, which is not correct in our case. So we cut these 2 lines. Instead of connecting them in this order, we first start with our vector here, hook it up, so we get now a vector multiplication, which our offset is now happy with because vector and vector works together. And now we can take a float and hook it into the second input. And this works. You see, now we don't have dotted lines anymore, and we get exactly what we are after. Let's try to make this a little bit more tidy. Go outside and test this. For this, I would like to have a little bit longer timeline, so I clicked here on the global animation options and we take 1000 frames here, close this. And if we press now play, nothing happens anymore. Why? Because our direction is 0, 0, 0. Now try it upwards. So we set the Y component to 1 and it works. Fine. Remove that in X direction. Okay, works fine. And also in X direction. Okay. Now you can play with these values and you always can tell in which direction it flows and also how fast this effect will be. Great. The next thing we want to do is we need a user interface here for changing how this noise looks. We need bigger patches here. So dive back into the system here. And to change now how this noise here looks, we look into the options which we have. One is the frequency. So if we have, for example, a different frequency, you get more or less fine details. Yeah, something like that here. So this is one way of changing the look of this noise. Also, we have here roughness, which looks really cool if we lower that. And we have a turbulence amount, which we maybe want to change. And maybe also here the kind of noise we want to work with. Okay, so how to get all these values outside? I showed you the manual way of adding parameters from the outside. It would be ridiculous to do this here now for every of these inputs which we need. So for this, we go a faster way. To promote now the frequency, for example, you can do one of two things. One is you go here to the frequency and click here this little cogwheel and say promote this parameter. This is one way of doing it. And if you do that, you see that here this little flag comes into place. Or you also can go over here a value, for example, roughness, hold down your middle mouse button key and click here promote parameter. And that's exactly the thing I would do. I go here and do that here for all of these values. And the question really often in my trainings is, what are these flags here for? These flags here are in reality a collapsed parameter node. So if I select, for example, now the frequency here, this little flag you see, it's a parameter node. And we have now all the values filled out from this node here. And if you make a double click on it, you see you can expand it again, so you can change here the names and all these things. To get rid of that, you can make here a right mouse button click, not a right mouse button click, sorry, a middle mouse button click here over this port where it sits. And then we can tell hide input nodes, and so you get this flag here back if you need that. Okay, now we have on our user interface all the settings which we promoted. So we can now change this here to an alligator noise, for example, and get a look like this, or your original Perlin sparse convolution, and so on. Yeah, this looks a little bit like the effect we had before. Great. To get dividers here between them, what you can do is you can go here to this little cogwheel and change here the parameter interface. So you get all the parameters which we have in the moment on our node here. And here are all the fields which we have added. And what I do now in the types, I search for a separator, which is here, and I drag it between, for example, the speed, direction, and the frequency, so that we get here a separation. I think this looks better for me, so that I can read a little bit better. This is the noise, and these are the animation parameters. The next thing I'm after is I want to remap these values a little bit, so that I can tell now the system which values I want to use and which values I don't want to use. And to do that, we use a little node setup. We need, on one case, a spline ramp, which we use for cropping. And because the spline ramp needs normally values between 0 and 1, we have to make sure that the values we generate here are between 0 and 1. But I don't have any clue which values we get, and every noise gets different output values. So to help me to see that, there are two ways. If you are in development like this, you can hold down the X key here, then you get a little eye, and you can click here on the output which you want to visualize, and you get a visualizer node here. And if you select the visualizer node and go to its parameters, you see you can tell now which type of visualizer you want to have. And normally it works here now with the color which we had before because you used it in CD. But yeah, this is a visualization. What it also outputs is in the geometry spreadsheet, which I add now here to my user interface by clicking here on this white arrow, split the pane top and bottom, and set by a right mouse button click here on the name this tab here to a geometry spreadsheet. I also get here the output of the visualizer. You see now we have values. And if you want, you can sort them by clicking on the top of the columns. And you see in the moment we have the lowest number is minus 0.5 and the highest number is 0.5 in the positive direction. So now we have an idea. So the visualizer is good in authoring time. If you want to see it from the outside or later without changing all of that, what I normally do is I take a bind export, which helps me to bring attributes to the outside. And I name this bind inside of this name field as helper. And now I hook this up here. That means I get now here a helper column. And it also works if I'm outside. I select this node and I always see here this helper column. And so I can now analyze the data stream. Okay. Now, we know that our values are between minus 0.5 and plus 0.5. What I need for my ramp is a value between 0 and 1. And to fit that, we use exactly a fit node. Okay. So, add a fit node here. Okay. And if you want, you can hook up the CD also there. And what you do in the fit node is you have a minimum and a maximum value, and you remap it to the destination minimum and maximum. This is something we want to do outside because that makes it more flexible. If we change the noise, we also can remap it from the outside. So I promote now the source minimum and the source maximum here to the outside. I select this little collapsed node here. And source min is a good name, but I say this is the minimum noise and this here is the maximum noise. Okay. And we have our helper in place. That's good. So if we go now outside and work with that, we can scrub somewhere and we only want to see the helper in this list. So go here to the attributes in the Geometry Spreadsheet and write helper. So we only get this column here. And now you see our values are now between 0.6 and 0. So these are now our two values. And this means we cropped a part of that. So what we now can do is we go to minimum noise and say we have values which are negative 0.5 and we have values which are positive 0.5. And now we get a mapping between these two values. And that's exactly the thing I'm after. And to make this more tidy again, take another separator and we add it here. Okay, better. And now we can use for the output here, you saw that the color hasn't changed. So now we see it something like that. Because I don't want to have it in the normals. Yeah. We can now add our spline ramp. So take a ramp node and the ramp is named ramp parameter. We switch it from an RGB ramp to a spline ramp. And now we take this stream here. The helper stays here because we always want to see what are the original values which we have. And the output is then again on CD, for example. That's it. Question arises, why is now everything black? The ramp here is linear, but why is everything black? Because of the default value. If you go outside, you see that the ramp is now working directly, and you see the ramp has a default value of 0. So that's the reason why you don't see anything. So you can select here the last grabber and move it up completely to 1, and now you see a direct connection between the inside and the outside, which we had before. And now you can play with that. So if you now press play here, you see it's still moving, but not so strong. And if you look into our helper here, the mapping is not correct what we want. So we can say -1 to +1, for example, or we can play with these values a little bit farther. So 0.4 to 0.6 or -0.4. You see, you search for something which makes sense from your output of the noise here. And then you can go in here and change with the ramp which part you want to see and where you want to have gaps. And what I want is I only want to use this middle part. So I set another point here, which I then bring down to 0 again. And if you now press play, we are really close at the effect we had before. Great. So let's dive in again. And I want to have this window here in full screen, so Command B over this window to see everything here. This ramp here selects which part we want to use, and in the moment we are only changing CD, which is a good helper for me to see what's going on. But what we want to do is now we want to scale the points up and down. And for this, Houdini has its predefined attribute name, which also Mantra and other external renderers understand, and this is the attribute with the name pscale. So what we want is that we now take this output here, which is a float, and export this value as a pscale value. To export something, we have learned that we have this bind export node here. So we take another bind export node and we hook it up. And now you have to type it correctly. It's pscale in lower letters, and it has to be a float. Be aware that here are some really interesting settings. One setting is that the type is always overwritten by this input, but this here is float, so everything will be fine. And that the export only happens if the input is connected. So if you forget this line, yeah, it doesn't work at all. So now we have outputted a pscale. And this pscale, if you now look at it, we can remove here now our filter. You get everything else. And a little tip, if you want to see only some of these parameters, you can type here, for example, you can want to see pscale, and then you make an empty space and say helper. And if you now press enter, you see only these two columns. And now you see, if I sort pscale, we have some points which have later a scale of 0, and we have some points which have a scale nearly at 1. And that's exactly the output we built in our setup. If you now render this, and I will do that now directly here, I go to the render view and I click here render, you will see that, the result is not exactly what we are after, because the biggest point will be in Mantra now 1 meter. And this is extremely big. Yeah, you see it. It's too big for our taste. So what we need is another multiplier which we use to scale the overall size of points. And this is something we can do directly here. So pscale is the final output. What we need is an input, a scalar. So let's take a parameter node and say point scalar is a good name. And for the label, I say point scale. Normal point scale can be 1, which is 1 meter. It's really big. The float range we can change, but we don't need to set this. And then we multiply our pscale here with this multiplier. So if we now go back here, I save, I render this. And while it's generating the scene, we can now see here's our point scale, which is 1. And so I would expect that the points are exactly 1 meter again. And then I can lower this value. So we multiply now all these points down. And now you see more and more that we come into point sizes which make more sense for us. Now let's search something which we like, 0.005. Yeah, now we have nice points. And that is the way of setting all the points up. You see, now you have the effect which we were after. It works, and these values here also work. The next or last step would be how to make a shader and how to render this. But this is a topic for the next tutorial. So I close this by adding a null at the end, and we say these are the points. I press the C key to grab a color palette, press C again. Okay, and now we can say these are the points. Yeah, I hope this helps you to set up something like this. If you have a question, please use the comments section under this video. And if you want to learn more, my name is Helge Maus from pixeltrain. Please write me and I will be happy to help you.